Okay. Hello friends, hello students. In this video, we'll see file allocation methods as we discussed in the last video. Uh, File management components and file accessing methods. So among from that, three accessing methods are used. First one, sequential access method, then random or direct access method, and then third one the index access method, right? So next one, file allocation method in operating system. The allocation method defines how files are organized at disk. That means when files, those are stored, interrelated files and data, those are stored in a disk blocks, then how it is arranged and how it is managed. So that information which is known as a file allocation. So there are some methods, those are allocate or files, those are stored in a disk blocks. So mainly basically three methods those are used by any operating system. First one, contiguous memory allocation or contiguous file allocation, linked file allocation, and then next one the indexed file allocation. Okay, so nothing but allocation method, nothing but files are stored in a particular disk blocks, how it stores that methods. For that some methods are used. So basically we will see three methods: contiguous file allocation, linked file allocation, and then next one the indexed file allocation. Okay, so among from that, first one, contiguous file allocation. Contiguous name itself indicate that we have to arrange the uh, file data or file in a contiguous manner or sequential manner. So in this schema, file is made from contiguous set of blocks on a disk. Contiguous set of blocks on the disk. That means uh, the files. Suppose we'll see here. Suppose this is a disk. In that we have to store. Suppose first file A. Okay. So in that file A, so file A contents those are stored from a second block. After that third block and then next one the fourth block. Suppose file A starting block is a 2 and length is a 3. That means from 3 blocks those are allocated as per length to the file A. After that the next upcoming block or starting block which is allocated for by file B. That means if suppose it is a ith block which is allocated to the file A, then I plus 1 block which is allocated to the file B. No need to allocate file B which start from the fifth block. Okay, it can starts from ninth block, eighth block or sixth block, but it arrange sequentially. That means it cannot allocate it from 0 to 1. Okay, first file A which starts from the 2, then 3 and then 4. The next block I must be at 4 plus ith locations. Okay, so this type of an allocations or this type of an locations memory which is known as a contiguous file allocation. Okay, so linear ordering on the disk is defined by the disk addresses. In this schema, only one job in accessing the disk block B. After that, it accesses the block B plus 1. As I said, file A which starts from the start 2 block, okay, and length having is a 3. That means second block, third block and fourth block which is allocated to the file A. Suppose that fourth block is a bth location, then always next file which is starting from the B plus ith location. So B plus ith, that means file B which starts from the ninth location, and then as length of 5, it allocates sequentially 5 blocks to the there. Okay, then next one, next file C which is allocated from the 18, next allocate some blocks, 8 blocks which is allocated to the file C, and then next one the file E, and then next one the file D. That means all the blocks related to the file, those are arranged or those are allocated in a continuous manner. That means for file A, 3 blocks are required. 3 length is file of A is 3. That means 3 blocks are required. So file A 2 plus 3 plus 4. Those are allocated to only file A. It will not happen for file A. Second block which is allocated to the 2. Next third block which is allocated to the 8. And fourth block, that means third block, last one, fourth block which is allocated to the 14. But obvious it is a contiguous allocation. That means it allocated 3 blocks sequential manner. That means B plus I. Okay. So this type of an allocation method which is known as an contiguous memory allocation, file allocations. Okay. So what is the advantage and disadvantage of that? As it is a simple to implement, as we have to allocate just depends on the length, we have to allocate a number of blocks related to the file from this. We can directly access a particular block related to a particular file. That means suppose from this example I want to access a block B. That means from ninth block I can directly access a data related to that one. That means file B up to the 14. Okay. So it is easy in a contiguous memory allocations. But what is the disadvantage of this? As we know, the number of blocks, those are free here. We cannot allocate them to other files, right? So memory inefficiently used here, or disk space which is inefficiently used by the computer system. So this is the disadvantage of an contiguous allocations. Okay. The next one, it suffers from the internal and external fragmentations. In last lecture or last video, we already see internal fragmentation and external fragmentation, right? That means you have to divide the blocks into number of frames, and that frames are allocated to particular swap in and swap out process. So, which is not allowed in a contiguous memory allocations. Okay. The next one, to overcome the disadvantage of a contiguous memory allocations, those are covered in a linked allocation or non-contiguous allocation. So what will happen in a linked allocation? Instead of allocating a particular file blocks to the sequential manner, we have to maintain one linked list. Okay, so linked list automatically, in linked list there are 2 pointers are maintained. First pointer is a start of a file block, and next pointer, it points to the next block from that particular file. So automatically it maintain links related to the blocks, those are stored at a disk. So there is no need to allocate blocks in a contiguous manner. Suppose this file, it requires, it's starting from the 9 and 4 blocks are required. So first of all it will goes to the 9, then next block which is allocated to the 2, then next 16, then next one the 1. That means we can allocate any block to the any file, just we have to maintain the links over there. So that's why it is known as a linked allocations. So it overcome the advantage disadvantage of an contiguous memory allocations. Okay, so it supports random access file, but obvious depends on the random access, we can allocate a particular block from the disk, then fast access to the file system, then free from problem of an external fragmentations. Okay, so what is the advantage of this? In terms of file size, this scheme is very flexible. Increase or decrease the file size depends, as we are maintaining the list, linked list over there. Then what is the disadvantage of this? Large number of blocks, 6, because of file blocks are randomly distributed over a disk. As it is an advantage, which is act as also disadvantage. As we know, the blocks of a file, those are randomly selected, right? So they're randomly selected, that means there is a no number of seek time to identify a particular block, which is automatically increases. After one, which block we have to read. After two, which block we have to read. So uh, that means finding a particular disk block, seek time is more required. So it is again disadvantage of this. The pointer extra overrode on the system due to the linked list. And then next, advantages and disadvantage of both, those are overcome in a next file memory allocation, which is known as a indexed allocations. Okay, so indexed allocation means what? Special block known as an index block contain the pointer of all blocks occupied by a file. That means like a book. First of all, you have to maintain index and depends on the page in. Special block known as an index block contains the pointer to all blocks occupied by a file. Okay, that means like a page, book, we can maintain a page index and depends on the page index we can identify a particular page from a book, right? So index allocation is nothing but an book page indices, right? Each file contains is index which in the form of an array disk of a particular block addresses. If ith entry in an index block points to the ith block of a file. That means suppose in your index file, second entry is maintained. So that second entry allocated to the second block from this. If it is maintained sixth block, it related to the sixth block of a file, right? So this type of an information or this type of an allocation done in a indexed allocations. The next one, the addresses of the index block is maintained by the directory. All the addresses, those are related to the index maintained by the directory itself. Okay. The next one, so this is a how index allocation is done. Here index allocations the table is maintained. So 1, 8, 3, 4, 15. That means 1 which is related to the 1 block from disk, 8 which is related to the 8th block from disk, likewise 28 which is related to the 20th block from disk. So likewise index allocation is done. So what is the advantage of this? It supports the random access files. It provides the fast access to a particular file blocks as it is maintained in an index page. What is the disadvantage of this? We have to maintain extra pointer heads. Those are again linked to the particular disk. That means we have to maintain this extra pointers. Again, that will retrieve the information from the disk. So it is then again this one of the disadvantage of an indexed allocation. For large file system, it is difficult to the handling all the indices. So these are disadvantage of the indexed allocation methods. Okay, so uh, up to this, all which is related to the file system. After that, we will see the directory and directory structures. Okay, so in the next video or next lesson, we will see directory and operations related to the directory. That is all till now we are covered file management, file accessing methods, and file allocation method. Right? After that, we have to all this we have to see for an directory. There are two parts: file and directory. Till now, file is completed. Now we are shifted to the directory, which is covered in a next session. Okay. Thank you.